All right, guys, this is day one of our Unit 8. Okay, we're talking about weather climate. Okay, and we're going to continue with our packet. All right, so again, this is week 2 of our weather and climate packet. So, hi there, let's combine science and reading skills to study weather and climate for our next unit. Okay, how can we predict the unknown? So, we're going to read Earth's weather climate on pages 6 through 9. So, go to this packet right here and go to page 6. All right, we're going to read pages 6 through 9.
Short read 2. Remember to annotate as you read.
Earth's Weather and Climate by Laura McDonald. What is the weather like right now? Weather describes the atmosphere's conditions in a certain place at a given moment in time. Climate is different. Climate describes the average weather patterns of that place over long periods of time. Climate describes the average weather of the seasons. It also describes possible weather extremes like tornadoes, hurricanes, droughts, or rainy periods. Weather can change from minute to minute, hour to hour, and day to day. Climate is determined by tracking a region's weather patterns for decades. How do scientists track these weather patterns? Scientists measure different weather features. They measure air temperature, which is how hot or cold a place is. They measure the amount of precipitation that falls as rain, snow, or sleet from the sky. They also measure other factors, such as wind, humidity, and cloud cover. Scientists use different tools to measure these factors. They record their measurements and observations. Then they use this data to figure out the weather patterns of a region. Using this information, they can define the climate type.
Cumulus, nimbus, stratus. Cloud types. Clouds are water vapor floating in the air. There are many different types of clouds. The shape, appearance, and elevation of clouds can help people predict weather. Cumulus clouds are puffy and white. They are often called fair weather clouds. Nimbus clouds are dark and gray. They are considered storm clouds. Flat, hazy stratus clouds are associated with light rain, but generally stable weather. Two important factors that determine climate are air temperature and precipitation. Scientists measure these factors over time to make weather predictions. They also use this data to define a region's climate. Temperature and precipitation chart. Yearly. Precipitation, millimeters. Month. Temperature, Celsius.
Turn the page, and then we're reading this section. Okay.
Earth's climate zones. Tropical. Tropical wet. Tropical wet and dry. Dry. Semi-arid. Arid. Moderate. Mediterranean. Humid subtropical. Marine west coast. Continental. Humid continental. Subarctic. Polar. Tundra. Ice cap. Highlands. Non-permanent ice.
Some climates are hot and rainy. Others tend to be cold and dry. These different climates are caused by different factors. For example, regions closer to the equator receive more direct sunlight. As a result, they tend to be warmer. Places closer to water have more moisture or humidity in the air. As a result, they tend to get more rainfall. Regions far from the equator tend to be cold. Places far from water tend to be dry. Land features and elevation, height above sea level, are also factors. As a result, Earth has several different climate zones. There are 5 main climate groups: tropical, dry, moderate, continental, and polar. Each climate has its own characteristics. Each climate also supports its own diverse forms of plant and animal life. Understanding a region's climate helps people predict what typical weather will be like throughout the year.
Tropical wet, arid, humid continental, polar ice cap.
Cool. All right. Let's go back. All right. So we went ahead and read pages 6 through 9. Now we're going to talk about key details and main idea, okay? It says find the key details and the main idea for each paragraph. So we're going to work on page 4 of our packet. So go to page 4 of this packet right here. It says Weather and Climate Workbook, Unit 8. And here's 4. Okay. I believe you already have the top part, right? Yes? So when we look at paragraph 2, okay, let's write some key details in paragraph 2. So we go back to the text. On page 6, paragraph 2 is right here. Okay. Some of the details there. Well, what do scientists measure? Now I'm going to go look at that paragraph. What do they measure? Look at paragraph 2. What do we measure every day? Oh, what's this? What are we measuring? The temperature, yes. Okay, so scientists measure air temperature. They also measure the amount of precipitation. What does that mean, precipitation? Falls from the sky. What? Rain, yes. Any moisture that comes from the sky is precipitation. Rain, snow. They measure wind, humidity, and cloud cover. Okay. Not clover, sorry. And cloud cover. So every time we recorded the information that we recorded on our graph, it's called data, okay? So what they also do is they record or they write down their data to figure out the weather pattern of an area. Okay. Okay, so we did details from paragraph 2. Now here's the main idea, okay? Scientists measure and track weather patterns. That's the other column. So this is the bottom section. Okay. I don't have boxes here to write, so I'm going to write them here. Okay. So this areas near the water tend to have more rain. And then regions closer to the equator. The equator is the imaginary line that goes around the planet. Okay. Regions closer to the equator or warmer while regions farther away are, so if regions closer to the equator are warmer, if they're farther away, they're what? Colder. All right. Okay, so we did details from paragraph 3. Now move over to the right and let's do what's the main idea there on paragraph 3. So it's like this. There are different factors that cause certain weather patterns.